All right, today we're going to take a look at section 6.8 law of signs without what we call the ambiguous case. So yesterday we worked with SOHCAHTOA, and one of the rules I said is that SOHCAHTOA only works on a right triangle. So if we take a look at the triangle we see we have angles that are 40 and 145. So if I do 180 minus 40 minus 45, that gives me 95 degrees, which means I don't have a right triangle. So why doesn't SOHCAHTOA work? And we can say we don't have a right triangle. Okay, so then we have to have another way to make this work. All right, so I'm going to prove part of law of signs, and then we'll use law of signs to solve some triangles. So we talked about yesterday how if we drop the height down here, I'm going to call that H, that we get a right angle. Okay, so if I want to use SOHCAHTOA and I want to use, say, angle A, okay, the opposite side, right, would be H, and then the hypotenuse over here would be C. So I know that sine of A is equal to the opposite, which is H over C. All right, if I want to do the same thing over here for side C, this side right here is still the opposite, but this time A is the hypotenuse. So I could do sine of angle C is equal to the opposite side, which is H over A. All right, so if I have, I have two different equations. They both have an H in them. So I'm going to solve for H. We could just put that over 1, cross multiply. I get H equals C times sine of A. Put this one over 1 and cross multiply. Now I get H is equal to A times sine of C. Okay, so since I have two things that are equal to H, I can set those two things equal to each other. So C times sine of A is equal to A times sine of C. And then to get the law of signs, I'm going to divide both sides by C, and then I'm also going to divide both sides by A. Okay, so that's going to make my law of signs show up. So in this one, I have C canceling out. Here I have A canceling out, and I get sine of A over little a, which remember is the side A, and then sine of C over little c. Okay, now this also works if I would have dropped the altitude from angle A instead. I could do the same thing with angle B. So we will get a third part of that law of signs, which is sine of B over B. So if you take a look at the next page, there is my law of signs. Obviously, it put it in alphabetical order where it put angle B in the middle. But we are looking at... we're going to use this now to solve anything that's not a right triangle. Okay, and there's basically three different possibilities. Okay, a triangle is ambiguous, which means there could be a second triangle when we are given only one angle. Okay, in this case, though, we're going to have three possibilities. You might not be able to you might not be able to find a triangle that works with the information given, and I'll show you how that happens. We can form one triangle, which is what we're going to look at today. And then tomorrow we're going to talk about what happens when two triangles are formed. So today we're just going to focus on parts 1 and part 2. Okay, so the first thing says solve the right triangle. So that means we're finding all the sides and all the angles. We're going to round each angle to the nearest 10th and then the sides to 2 decimal places or the 100th. Okay, so how do I know if it's ambiguous? We said that there's only one angle. So here I'm given two angles. So can it be ambiguous? No. So we know we're either getting no triangle or we're getting one triangle here because I was given two angles. So that means there is only one possibility for that angle right there. So at least, or at most, one triangle can be formed. Okay, so we just did that one up above, right? That was the same triangle we started with. So if I add those up, subtract from 180, I've got 95 degrees for angle C. So I didn't have to round that one at all. All right, so now we've got to label our sides. So opposite angle B, remember, is side B. Opposite angle A is little a. And then straight across from angle C, that 4 is side C. So what I'm going to do is I'm going to set up that law of signs. So I'm going to go sine of angle A, which is 45, over little a. And then I'm going to go sine of angle B, which is 40 degrees, over little b. And then I'm going to do sine of angle C, which is 95 degrees, and that's over little c, which is 4. Okay, so one of the things that you're always looking for in law of sines, in order to be able to use law of sines, you have to have what I call a full fraction. So I know the angle and I know its opposite side. Okay, so what I'm going to do is I'm going to take these two first because they're right next to each other. And we're going to solve this, right? We only have one missing piece. We're just missing b. So if I were to cross multiply and solve, we can get b pretty easily. So if I cross multiply here, I get b times sine of 95. And remember, you can go either way you want. And going the other way, I get 4 times sine of 40. To solve for b, I'm just going to divide both sides by sine of 95. And then I'm going to plug that into my calculator. Now, be careful. Make sure you close parentheses after sine. So I'm going to go 4 sine of 40. And sometimes it's easier to just hit enter and then divide by sine of 95. Now, remember, you should be in degree mode because we're talking about degrees. I'm going to go 2 decimal places. I got about 2.58 for b. Now, the downside here is I can't do Pythagorean theorem because there's no right triangle. So I've got to now use the first fraction and this last fraction, and I'm going to basically do the exact same thing. So I'm going to go sine of 45 over a equals sine of 95 over 4. I'm going to cross multiply, so I get a times sine of 95 equals 4 times sine of 45. I'm going to divide both sides by sine of 95. So a is approximately equal to, so again, I'm going to go 4 sine of 45, hit enter, or close your parenthesis, and then divide by sine of 95. And I get that one is approximately 2.84. Now, one of the things that we do know is that the larger the angle, the larger the side. So 95 is my biggest angle. That side was 4. That's my biggest side of all of them. A is my next biggest angle. So if you compare those two, A is just a little bit bigger than side B. So we know that that triangle makes sense, and we have now solved that triangle. All right, next one, it says, solve the following triangle. Can it be ambiguous? One of the other things, not only is it just one angle, we also have to have side angle. We could write it backwards as well, so that might help you remember it. You have to have two sides and an angle for this to happen. So normally I just look for one angle, and then it could be ambiguous because we have a couple different options for these angles, and we'll talk about that more tomorrow. But let's go ahead and set this one up. So I know that this is A, so this is little a. This is angle B, so that's little b. We've got side C, or angle C, so opposite that is side C. So I'm going to go ahead and set up my law of sines. So I've got sine of angle A, which is 60 over 4. So I'm happy there. I've got my full fraction. And then I'm going to go sine of angle B over 5. And then sine of angle C over little c, which we don't know. Okay, so let's go ahead and take a look at what do we have. Again, I've got my full fraction right here, so that's the one that I'm going to use. And since I don't have any information about angle C yet, which I can find once I find angle B, I'm going to use those two right there. So I'm going to cross multiply. I get 4 times sine of B equals 5 times sine of 60. I'm going to divide both sides by sine of B. All right, so now I get sine of B is equal to, oops, I don't want to divide by sine of B. Oops. I'm going to divide by 4. That would make way more sense. I'm going to divide both sides by 4, so the 4's cancel, and I get sine of B is equal to 5 sine of 60. I'm going to hit enter, divide by 4. And when I plug that into my calculator, I get 1.08. Well, I'm hoping right now when you see sine is equal to something more than 1, you know that that's not going to work, right? You could have kept going and you could have taken the sine inverse of both sides like we did yesterday, and then your calculator would give you an error. So in this case, we have no triangle that's possible, all right, because we cannot find an angle for angle B that is more than 1. All right, let's take a look at another example where we're going to solve the triangle. So again, this one gives me my two angles, so it cannot be ambiguous. If I add those angles up, that's 100. Subtract from 180, that gives us 80 right there. Label our sides. So opposite 40, or opposite angle A is A, opposite angle B is B, and opposite angle C is C. So we're going to go ahead and set up that law of sines and hope we have a full fraction. So right away, I've got sine of 40 over 4. So that one is nice. I've got my full fraction. Sine of 60 over B, and then sine of 80 over C. All right, just because they're next to each other, right? This is my full fraction right here. So I'm just going to pull these two first, and I'm going to find side B. Well, we already found angle C, so I'm going to put that over there. Angle C was 80 degrees. Now let's cross multiply to find side B. So I get B times sine of 40 equals 4 times sine of 60. To get B all by itself, I'm going to divide both sides by sine of 40. So B is, plug that into my calculator, 4 sine of 60, hit enter, divide by sine of 40, and I get 5.39 approximately. So B is 5.39. All right, so now I'm going to do the same thing there. I'm going to take now, let's see, I'm going to take this guy right here and then the one in front, and I'm going to set those equal to each other. Again, I don't like to use things that I solved for, like I mentioned yesterday. So even though I know B is approximately 5.39, that's a rounded number. So I really don't want to use this fraction. Otherwise, I could put those two together, but then my answer is going to be off a little bit. So use the one that, the full fraction that you were originally given. So I'm going to go sine of 40 over 4 equals sine of 80 over C. Cross multiply, we get C times sine of 40 equals 4 times sine of 80. Divide both sides by sine of 40, and I will get C. So I got 4 sine of 80, hit enter, divide by sine of 40, and I get 6.13. Okay, another thing I can look at is I know C was my biggest angle, so 6.13 is my biggest side. My next biggest angle was angle B, and we found B to be a little bit smaller, 5.39. And then my smallest angle was 40, angle A, and side A was 4. So that whole idea of the smallest angle has the smallest side and the largest angle has the largest side still holds true here. All right, let's take a look at a word problem. Oops. So it says, observers 2.3 miles apart see a hot air balloon in the sky. All right, so I'm going to put person 1 right here, and I'm going to put person 2 over here. Okay, and we know that in between them is 2.32 miles. All right, it says person 1 sees the balloon at an angle of elevation of 28 degrees. So that means that angle inside my triangle is 28 degrees. And it says person 2 sees that balloon at 37 degrees. Okay, and we want to find the height of the balloon. So I'm going to, or altitude, whatever. I'm going to just call it H for height. We want to figure out how high off the ground that balloon is. All right, so we actually do have a right angle here. However, if I look, I don't have, if I take a look at this triangle right here, I've got 37, I've got H, but I don't know any of the other sides. So remember, in order to do SOHCAHTOA, you need 2 of the 3 parts. Well, I only have 1 of 2 parts, so I need to find a third side. Now, I can find either the side on this, on the left side, I can find the side on the right side. I'm going to focus on this triangle right here, and I'm going to look for this side, which, let's see, if I call this A, if I call this B, and if I call this C, this would be, if I look at the big triangle, straight across from A would be A, and then this guy on the bottom here would be straight across from angle B, so this would be little b. All right, so I don't have enough to use SOHCAHTOA yet. Even on the other triangle, I just have 28 and H. I don't know any of the other sides. So I'm going to go ahead and use law of sines to find side A. Okay, so I know I've got sine of 28, which is angle A, over little a. And then if I use angle B, I've got sine of angle B, which I can actually find this angle right here. So I know that I have this big triangle, and I know these two are 28 and 37. So if I take 180 and subtract 28 and 37, That gives me this angle up here is 115 degrees. So that's the whole angle, not the angle just inside the triangle. So angle B is 115 and side B is 2.32. So that right there, I could continue and I can do sine of angle C, which is 37 over C, but I'm not looking for that. I want to find side A, and that is enough to let me find side A. So I don't have to finish the whole law of sines because I'm just going to focus on these two parts right here. So when I cross multiply, I get A times sine of 115 equals 232 times sine of 28. Divide both sides by sine of 115. So I get side A is 2.32 sine of 28. I hit enter. I divide by sine of 115. And I have 1.20. All right, so side A is 1.20. So now if I pull that right triangle out here, the one on the right, okay, I know this is 37 degrees. I know the height, and now I know this is 120. Okay, so now I have enough for SOHCAHTOA. This is my opposite side. This is my hypotenuse. So just by coincidence, I'm using sine, even though we could have used cosine or tangent, and it's not law of sines, it's just sine. So sine of 37 is equal to the height over 1.20. So that is good practice of what we did yesterday. So put it over 1, cross multiply, and I get my height is 120 times sine of 37. So 1.20 times sine of 37 is approximately 0.72, and I think we were in miles. Yep, so the height of that air balloon is about 0.72 miles above the ground. All right, I will answer all questions tomorrow. Work on the homework. Thanks.